morning, one and all. Today we will be discussing about the mixture with heating jacket. So the learning outcomes of mixture with heating jacket is: first we are going to identify what are all the components present in the mixture with the heating jacket, and we will be doing two experiments to verify the mass balance of the mixture with the heating jacket, to verify the energy balance of the model, and we will be activating some malfunctions, and we are going to write the consequences. So this is the graphical display of mixture with heating jacket of our given model. So there are two inlets. This is the first inlet, number 1, and this is number 2 inlet. Water and methanol are coming into this mixture, this tank T150, and for heating this water and methanol mixture, we are passing the hot water from this inlet number 3. So the hot water inlet is coming in this direction, and the hot water is leaving here. This is the outlet of the hot water, the outlet of the hot water. So the purpose of mixture with heating jacket is to convert the liquefied the water methanol mixture by heating that water methanol mixture inside a jacket, inside a tank, and we will be getting a mixed stream outlet in the end. This is the outlet. So here we are having some special utilities, that is, this is a pump, this is the motor, and this is for operating the stirrer. This component is called as stirrer. Stirrer is nothing but to mix water and methanol inside the tank, the stirrer. And here the next slide will be, and stirrer is to mix the methanol and water inside the tank, already we have discussed. And specially we will be having another special control called as cascade control. Cascade control means when the two controllers are connected in series, it is said to be as cascaded. Here we are having FC160 and LC150 are connected in series, where the output of LC150, it is going to control the flow controller FC160. So that LC150 will be acting as the master controller, and the next one will be acting as the slave controller. This arrangement is called as cascade control. So far we have discussed automatic, manual, and third one is called as cascading control. And this is the arrangement of our mixture with heating jacket model. And here we are doing the first experiment, mass balance. So under mass balance, under steady state condition, the mass output and mass input, it should be equal. For example, here we are having a tank, and in this tank we are passing water and methanol, and outlet is the mixed stream. So we are having two inlet and one outlet. So mass inlet Fi110, that is the water inlet, this is water, and this is methanol, and it should be equal to the output, that is the mixed stream. So first this one first reading, this is the initial condition reading, starting condition reading, and after that I simulated the model, and I have given the values, and which is showing the mass balance of the mixture with heating jacket. When we will be having mass imbalance means if there is any malfunction, any problem, any fault condition occurring inside the pipeline or inside the tank, maybe the tank is leakaging, then the mass balance will not be achieved. This is for the first experiment. Second experiment, energy balance. This energy balance already we have discussed with heat exchanger. The same formula here we are using. So the heat energy given out by mixed stream, that is the heat energy by the hot water, because heating jacket is giving out the hot water, and heat energy taken by the inlet, it should be equal. Then the energy balance is achieved. So first one is I have taken the values. So Fi130 is the hot water inlet. And multiply density of water. Why we are multiplying density of water means, in the model the mass flow rate is given by meter cube per hour. So this is given by meter cube per hour. Okay, so density, what is the formula for density? Kilogram divided by meter cube. So we can cancel meter cube. Multiply with Cp is the specific heat capacity, and the temperature difference. Specific heat capacity and the temperature difference. And by the first calculation I have made it for our initial conditions from the model, and here for the inlet heat energy we have to add the two inlets. So this is the first formula, Fi110, this is for water, and plus there are two inlets. So second one we have to do it for methanol. This is for methanol. The same thing, but the density of methanol and Cp value of methanol are changed, and I have given the density of water, specific heat capacity of methanol, water, and here this is the density of methanol and specific heat capacity of methanol, which are all constant. And now we are getting the heat energy given out by the hot water. It is not mixed stream, it is hot water. And heat energy taken by the inlet, both are approximately equal. This is how the energy balance of the heat exchanger is done. And malfunctions, there are so many malfunctions. We are having 11 malfunctions, and I have activated only one malfunction. that is tank heating jacket fouling. We know already, we have discussed about fouling in heat exchanger. Fouling means deposits of unwanted particles, solid particles inside the pipeline, which will cause the decrease in the flow rate as well as in the heat exchanger that is what heat exchanger rate. Okay, so heat transfer coefficient, the values will be decreased. For that, I have activated the simulation, and this is the final picture of the last simulated picture of tank heating jacket fouling. So you can do the comparison, which value is increasing, which values are decreasing. Initially, the value of hot water jacket inlet is 135. Now it is 225.24, and initially the pump HP is different. Now the pump HP is changed. The motor current is also increased a little bit. So you can take the comparison, by which you can write a report why the flow is increasing, why the ampere rate is going high or low, what is the whether the mass balance, whether the energy is balanced correctly. So what will be happening for the fouling, how you can come out of fouling, you can give the some remedial actions by which you can conclude this topic. This is what about mixture with heating jacket model. And if you want anything, clarification or anything, please free to call me or mail me. I will be helping you at any time. Thanks for listening. Have a good day.